When you deal with distributed systems, things can go wrong. Have you ever been in a situation in which you were about to deploy the new version of your code, either via CLI or through a button in a UI, and before you push that button to deploy your code, you start having sweaty hands? You're like, I wonder if this is going to go well. And if things go wrong, how do I even check? How do I know that my system is behaving as I intended it to be? That cannot be necessarily about deployments. It can be also when you are on call. So if you work for a big company on a critical system or in the financial services, yeah, you might be on call. So sometimes you might be even woken up in the night, sometimes from another team that tells you, hey, your system is down. What's happening? And you're like, wow, we didn't even know, and it's our system. So things can go wrong. That's why resilience is important. And a system is resilience when it has the ability to recover from failure. So developers, tech leads, architects who are here, if you're interested in understanding what are some patterns, what are some examples that we can follow to design and build the resilient backend APIs in the cloud, well, you are in a good place. You're in a good place. And today, I'm going to be walking through some patterns, some examples. From an architectural perspective, I will share some code, and at the end, I will also do a small demo to show you what is even possible. And yeah, let's get started. So let's start with a very classical, typical web application. I have my client, my user, they use my product, and I host my application, which has like front-end, back-end, in a web server, which has allocated some certain capacity, including CPU and memory, but I'm simplifying here. And so far, so good. We deployed in production. My application works as expected until one day we get more traffic than usual, something unexpected, and that server goes down because, of course, the capacity, the allocated CPU and memory within that server is not unlimited. Everything is limited. And the more HTTP requests, the more clients perform operation, the higher the spike of traffic, then my system is down, and this has an impact on my overall application. But this has an impact not only from a technical perspective, but also for my business, because I'm not able to fulfill, and this is especially a problem if you have like critical application, things that have to be like a matter of like life or death sometimes, or in the fintech sector when there is like a low latency requirements, things need to be up as much as possible. But the problem might not necessarily be inside my application, maybe because the resources allocated were exhausted, maybe because somebody deployed something that introduces a bug and then the backend API returns 500 all the time. That can be an example of what can go wrong. But we have other examples, like maybe somewhere, let's say that I also, as a disclaimer, my system does not operate in a bubble. My system most likely interfaces, talks to other dependencies, like maybe other teams, backend teams within my organization, maybe external APIs from vendors, and so on. So my system interacts with the external world, and as part of this can also, by adding dependency, this has an effect on my availability too. So things can go wrong around the network connectivity, for example, between my service and the service of somebody else in my organization. Or maybe the connectivity is okay, but one of the downstream dependencies or upstream dependencies have a problem. So here, maybe something goes wrong, and that has a potentially a cascade effect on everything else in the chain. So how can we solve that? So let's try to focus first on the one of the failure modes that I mentioned, which is exhaustion of available resources. So let's have a look again at the use case of this server that cannot hold the capacity and it just is unavailable or returning 400 or errors to the clients. So what are some things that I can improve about this? How can I make this better? How can I make this more resilient, more available? So first of all, I'm seeing that I have this server, which is one, and immediately we can say, oh, this is a single point of failure. Like if the server goes down, things go down for the whole application. And by the way, when I say whole application, I mean both front-end and back-end. So because they are co-located, that means that if the underlying infrastructure that hosts my front-end or back-end goes down, nothing is available. Not the front-end component, not the back-end component. On top of this, not only I have to take care as a developer potentially of like the availability or resilience of this architecture, I also have to manage the underlying operating system. I have to patch it. So that introduces also other things that I have to be careful of, because if there is a problem during the maintenance of the server, then it's up to me to kind of fix it. So this is just some of the problems or their failure modes that I can see here. But what would be maybe a better way to address this? Or to make it more available, more fault tolerant? So Luciano before me, he already explained very in-depth like the concept of serverless. So I will not go super deep on this, but I will just refresh in this. As in here, you can see a serverless architecture. So first of all, what I did is that in here, in my Amazon Simple Storage Services, which I will call S3, this is an object storage service where I put only the front-end assets, only that. So that means HTML, CSS, images, JavaScript, and so on, scripts. And that means that potentially somebody who hits the homepage of my system, of my web page, at the beginning, if this is available, when I load the page, I'm already able to receive the static assets, to render something. That is already a different kind of user experience compared to the situation that I had before. So this is where I store my static assets, and this represents, let's say, my front-end tier. In here, in the bottom, this represents my backend API, and to host that backend API, I decided that for this use case, I will use an Amazon API gateway, which is a service that allows you to build highly resilient and scalable APIs. I integrate my API, which is, again, the entry point of my backend API, with AWS Lambda, which was also mentioned by Luciano before. And in here, the AWS Lambda is a service that allows you to essentially host backend code without having to manage any server, because it's managed by AWS. So it's the way you feed this code to the Lambda is like to create, you provide a code in the format of like a function. And that function represents my business logic, a JavaScript function, or a TypeScript function, if you will. And this Lambda then stores information on an Amazon DynamoDB table, which is essentially a NoSQL database, which you can use to obtain single-digit millisecond latency at scale, regardless of the amount of data that you have into the table, which is, as you can imagine, contributed to the overall resilience of the architecture. On top of this, I decided to use Amazon CloudFront as a CDN service, so a content delivery network, to build the static content and potentially some responses from the backend that can be cached. So I want to use this CDN to be closer to the edge, to the end user, reduce latency, but also potentially, in case something goes wrong, I can attach a firewall on the CloudFront level, so then I don't have an impact on the regional stack that is here. So this is just an example, and I said at the beginning that this is a serverless application, which means, again, that you don't have to maintain and patch the underlying server and operating system that is hosting your application. You just have to build the business logic. So this is just one example. But what about, so my system is successful. We are a startup, we did a pilot, and we want to extend the functionality. We just don't want to have like a simple delete or create operation. We want to make it more interesting for our customers, which means that we need to start building new features. And one of these new features is, for instance, add an image processing functionality, a media processing functionality, something else. So let's say that my customer should be able to upload an image, the image gets resized, and I want to be able to store that information on DynamoDB, and I want to be able to store the processed image, the resized image, on where the static assets are, which is also an Amazon S3, like an S3 bucket. So the problem that we have now is that, okay, this looks good so far, this works, but with this new functionality, one thing that you will see is that processing an image takes time. Like, it takes, let's say, seconds. If you will, it could be like you have to kind of like store the data in the database. You maybe have to use some sort of open source tool to process it. If you have a video, maybe you want to use FFmpeg. So there is, like, you can use some libraries, but it takes time. And the consequence of this is that if I store my business logic all in my Lambda function in this component as it is, that means that by the time I finish with the processing, the customer will probably wait many seconds. And you can imagine if you had more and more customers doing the same operation, or more and more and more, we kind of probably will be in the same situation as we were before, because the latency of this Lambda function will have an impact on the overall availability of the application. So how can we solve this? The idea is that you decouple this long-running transaction and you essentially create a separate architectural component. So the moment that you upload a file on your S3 bucket, an event occurs. So it's not that I poll, it's not that I do things synchronously. I make my systems, instead of like commanding my system to do something about the image, I make my system observable. So then when an event, say the system change, in this case, an image has been uploaded, other system observe that change, that signal, and act on it. And the way you can do is by using Amazon Event Bridge, which is a managed service that allows you to essentially listen to events that happen in your AWS environment. So let's say there is an event that is about, there is an upload image event, and then I want to add a queue. So queue allows me to kind of buffer these events, so then we don't need to have this image processed in real time. We can afford to wait a couple of seconds. So we want to add a queue. So then if we have like a spike of hundreds of thousands people doing the same, we can buffer that without an impact on the overall availability of the system. And of course, we want to store the metadata in our DynamoDB table and also store the image that is being resized in my S3 bucket. Okay, now that we have this application, if you remember at the beginning, I mentioned something like, okay, when you deploy, the question is, how will my system behave? And the second question is, how do I know how my system behaves? Because it's not the same. It's not the same. The problem when you have a distributed systems is that you want, in order to be resilient, you also need an understanding of the health of your system, an insight into the health of your system at any time without deploying and without changing your code on the fly. And that is not a given. That is not a given. So how can I improve my applications, my JavaScript application or TypeScript applications, so then I'm able to gather that insight on the fly? So the concept of logging is essentially, I want my system to emit strings of text throughout my source code. So let's say before, I want to say, okay, at this time of my code, I want to have information about, okay, I got this parameter and I'm returning this parameter. I got this value from the database, or I'm returning this to my client. So I want to be able to get that information in a human-readable way, so then I can, when things go wrong, I want to be really clear on what's happening, for instance, in an invocation, a Lambda invocation. And the end goal is that I want to write the least amount of code as possible and get the most information that I need out of it. And you might need, okay, maybe I can have a string, something like, okay, this is a file, this is some metadata around this file that I uploaded and so on. No, this is not enough. What I want is this, which is essentially the output of this line. And you can get this by using AWS Lambda Power Tools for TypeScript, for instance, that was mentioned before. But what I want to highlight here is that, just because of formatting, theoretically, even with just one line of code, here is 3 for formatting, you can get a lot of context out of this system. And notice that it's not like a string of text, it's a JSON. And the advantage of using JSON to emit information about your system is that you can then send into some tooling, like either monitoring tooling or Amazon CloudWatch, and so on. So anything that is like equipped to parse this log. And the advantage of using JSON is that it's like a key value store format that allows you to get an insight and to search into it. And I will show you later how an example of how would it work. But yeah, so this gives me more information than just strings, because I know, okay, this is the unique identifier of my Lambda function. I know what is the function name, where is this store, where is this log generated. I have the request ID, which is the unique correlation ID that is generated by AWS. I have a timestamp. I know this is also, you have a service here. So I know which backend application generated this information. This is very useful if you send all your logs into a centralized place for governance. And then you have also details. So I know these are the details that I got from the log. And by the way, the details were added by me. I decide that in this log, I add this custom parameter. And this is what I get as an extra. So we have logs. We have also another problem sometimes. So let's say that my infrastructure works, but somehow, for instance, even though the Lambda function run, for instance, there is 0 file uploaded. There's no files. They don't get uploaded. How do I know that? How can I get that information? Because the infrastructure works. The Lambda runs. So I need to have like ways to kind of capture insights and telemetry out of my code that are not necessarily infrastructure related. So in the example before, we were focusing on the infrastructure side. Now I'm focusing on the business side. So if if my company offers a product or a feature that allows your customers to upload an image, but then things work, but there is no image upload, we have a problem. And how do we know that? You can do this, you can achieve this sort of insights by using custom metrics, which with Lambda Power Tools, you can use just with this one line of code, for instance, for this metric. So if I want to have a metric that tells me, oh, this file got uploaded, and I want to increase the count of this. I can also add some metadata, by the way, out of it. But in this case, I just want to know that something got uploaded. And then I can use this information to create, to let's say, use my monitoring tool. In this case, it's a CloudWatch, a screenshot of CloudWatch. I can use this information to create dashboards. So then my developers, my teammates, and so on, are able to see what is going on. In this case, I can see, okay, this is the amount of file uploaded by any company fictional name in my dev environment. But if I want, I can create like a custom metric that is also so I can also define custom parameters in my metric. So in this case, the custom parameter would be environment dev, and I can use like a SQL kind of syntax to create widgets, and not only for monitoring, but also for alerting. So this is information that you can use to create alerts, and because it's better to kind of know before the customer knows, especially for critical things. So this is one example of a use case. So let's say that if you remember the initial slides with the distributed system, we have different systems inside that talk to my system. Let's say that you're waking up in the night by your pager, your system is down, and you don't know if the reason is because it's your system falls or something is wrong with the dependencies that I have. Maybe they have a very high latency and there is a timeout issue. Maybe they return a 500 error. So how do I know in a very simple way that something is wrong with my code versus their code? This is an important question, also because you have to kind of understand and then manage the expectations with the other team and so on. But this is an example of how insights related to the way your application talks via HTTP to other dependencies is important. Not only that, but also to my database. So what if there is a problem with my database? What if there is a problem with this external API? I want to know. How do I know? So you can use traces for that. And by using Lambda Power Tools, the tracer utility, you can essentially instrument your Lambda function by using literally these 3 lines of code. And just by nature of these lines that are highlighted, don't know if I can get some insights related to the latency and the status code that are returned by dependencies within my code. So for instance here, I hope you can see it, but let's say that here I have information related to the latency and how the latency is mapped to different calls. So you see the calls, or like the calls inside my application, both the calls that are done to API, backend APIs, or databases, but also calls that are related inside the chain of my stack trace. Like I'm calling this function, oh, this function is very slow, this is the bottleneck. Like by using tracing, you can easily understand this, and this gives you the opportunity to act when there is a problem, because you can then easily identify, oh, here there is a problem with, here is not, but let's say in this case it returns a 200 status code, but maybe it could be that it returns a 400, so that's the problem. So this allows me to really act quickly and not to guess. So taking data-driven decision when I want to act on the availability of my system. Okay, so another problem that we might have is that if you remember the initial slide around the distributed system is that something might be wrong in the connectivity or in the response or in the request between systems as well. So how do I manage transaction, partial or intermittent failures? Let's go back to our API. So this is like a simple version of our simplified zoom-in version of our backend API. So my client is calling this API gateway, a Lambda function performs an operation like business logic out of it. And one day, my API is returning a 500 error. And then what I find out, possibly, is that the first time it returns a 500 error, but the second time it returns a 200. So this first operation was temporary. The system had an hiccup because maybe there is a network that went down. It can be, a connection that went down, but the system recovered itself because I built it in a way that automation, it recovered from failure in an automated way, or something happens and I don't have this problem anymore. So the first thing that you might think is like, okay, if this happens once in a while, then maybe what I can do is to implementing a retry strategy. So when this is like, for instance, I have my front end that calls my backend API, and the first time that something goes wrong, then I will do it. I will retry the call, and then I do it again, and then I do it again, and until when my code actually gets, like my front-end application gets like a successful response. Do you see a problem with this? I do, because the consequence of this is that, let's say that you have a number of HTTP requests, and then let's say that you have thousands of front-end clients that call your backend API, which returns potentially an error at the same time. Then what happens is that your front end, if you're not careful, then start essentially DDoSing your application. So you are DDoSing yourself, which is not something that I would advise, of course. So the idea behind this is that, yes, you should implement a retry strategy, but then you may want to look into exponential backoff. So if you look at this graph, each dot represents a call to your backend system from the client front-end perspective. So this is the amount of call at any given time, and this is the time that passes. So let's say in milliseconds. Within a second, we have this amount of API calls. Yep. The thing that you may notice is that, yes, things are, we are not looping in our code in a way that DDoS essentially our application. So we are adding a bit of time between each of these retries, which is called backoff with exponential backoff. So the first time we may retry after 2 seconds. The second time we may retry after 10 seconds. The third time we may retry after 1 minute. I'm not saying that this is how it should be, but I'm giving you an example of how would that look in practice. But the problem that we have now is that we still have this like pile of aggregated calls that are still impacting potentially our system. So how can we prevent this? We introduced jitter, which is a randomization of the time that it's implemented, that you adopt, while like repeating the calls. So instead of doing the calls, all of them, repeating the calls for all the clients at the same time with the same distance between one call and another, you have calls that happens at a random time with a cap. So this is better because it allows you to spread better the load on your system, and this is something that I would advise if you call any sort of backend APIs, please take into mind that this might be better for your APIs when you call them. Another aspect that I would like to talk about is chaos engineering. So what is chaos engineering? Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. This is a definition taken from Principle of Chaos, which I suggest you have a look. But let's say it's a who here is familiar with chaos engineering? Nice. So essentially, the idea behind chaos engineering is that you're able to introduce failure scenarios or failure events, inject failure events into your application without in a control situation. So let's say that you can choose between being waking up at night with something not working and decide to replicate that failure mode in a control environment so then you can actually act on it. I think I would choose the second one because it allows me to, first of all, understand, make me question, okay, what are the failure modes of my application? What can go wrong? Remember the question at the beginning? What can I do about it? And by doing this exercise, I can learn more about my system itself and kind of like proof or disprove my assumption of how the system will behave. And the way it works is that you have a system, you define a steady state, which is kind of how my system is supposed to behave as I expect. Then, once I define the steady state of my system, I formulate an hypothesis. This hypothesis about a system introduces a failure mode. So let's say the failure mode would be like a higher latency at a certain point. And the hypothesis needs to also introduce like a numeric outcome. So when this failure mode happens, then my system will react in this way. So for example, if my front-end client is calling my backend API and there is a latency of 10 seconds, then my system will be still available, but the user experience will be there is still going to be, for instance, 100% availability. This could be an hypothesis, something that I may or may not want to disprove. Then I run the experiment, then I verify what's happening after I run the experiment, so introducing the latency, and then I want to improve based on the observation that I've done. And because I like to make things interesting for myself, I'm going to do a demo, and this demo is not going to be about a success, it's going to be about a failure, a control failure, if you remember. So let's do this. Yes. So if you remember, we had this backend API. Can you all see? Hopefully, yes. So I have this Postman collection, which is calling this backend API, and I get some information, like some posts. So I can do a get of items. I can post, create an item. I can get one single item here, for example, and I can delete an item, in this case, posts. Think of this like a sort of social media app. And then, hello, I can do something about it. I can create one. In this case, I created this. This is my Twitter handle, and this is like the post that I just created. And I have a get, and I have delete. So how will I trigger let's say that I want to see how my system behaves when I introduce latency to it. The way I can do is that I can automatize a script, not locally, but in the cloud, by using SSM parameter, which is like a place where I store some configuration. And this is going to be some sort of feature flag. So in this case, every time that my Lambda function is called, I read the value of this configuration on the fly, and this configuration will tell me when the failure mode is enabled or not. So in this case, the failure mode, this is not enabled right now, but the failure mode will be latency. So I want to introduce latency. And what I want to do, I want to introduce a latency between 3,000 milliseconds and 10,000 milliseconds, and I want to see what happens. So the way I create this experiment is by using the AWS Fault Injection Simulator, which is a fully managed AWS service that allows you to perform chaos engineering. The advantage of using a managed service is that instead of doing like clicky on the console or creating a script, you can use infrastructure as code to create templates that are you build, and then you can share with your teammates. So let's start by starting the experiment. So if I go to experiment templates and I go to social media app, this is the template that I created. And essentially this template, this experiment template, will enable the flag to say, yes, I want to enable the latency. So I start the experiment. So let's wait a bit. I refresh. As you can see here, I get some information. I also get some logs related to the experiment. So the advantage is that I get some to do auditing on the experiments themselves. And in here, in the experiment, I decided to do some actions. In this case, are related to changing the value of this parameter, but it could be something related to your EC2 instances and so on. Let's see how it is. So now I see that it's running. So the parameter should be changed. So let's see what happens to my Lambda function. So remember, I want to introduce some latency. Uh-oh, something happened. This is not what I expected, potentially. I thought that my system would have more latency, but I didn't expect the internal server error. So let's have a look at the logs that I produced. So let me look at the logs that were generated by this Lambda function. And in this case, indeed, I can see the latest log stream. And let's see. This is not the one that I want. So let me see if I can. This is not the one. Sorry. Yes. Okay. So here I get some information. This is the metrics that I generated, as you can see. So this is telling me about the cold start. In here, I get information about the Lambda invocation event. And what I can say, what I can see is the function ID is something that I can use to correlate. I can see that this is coming from the social media app, so I'm able to understand, okay, is this even the log that I'm supposed to look? This is where I get information about the HTTP call that I created. And let me see, something in the past 30 minutes. So the problem that I'm getting essentially is, there you go, be here. Here is that if I go to my configuration, where is it? The timeout that I'm setting is 3 seconds. So if you remember in my configuration, I set a timeout that it was between 4 and 10 seconds. And the consequence of this is that my Lambda that I used, let me see if I can find it. The Lambda that I showed at the beginning, essentially, yes. This Lambda here is timing out, and it's returning a timeout error to my client. So in this way, I can see, so for instance, there are 2 things that I notice. My assumption is not correct because my system cannot withhold a latency that is higher than 3 seconds because of my Lambda configuration. And also, sorry, what am I doing? And also the second problem that I'm seeing now is that in my logs, I don't have any sort of telemetry that tells me when the I'm seeing that I'm like showing the wrong ones. Yeah, okay, so let's do this, actually. Let's do this. I finished the demo, so the takeaway from the demo is that I don't have information around my, my assumption about the latency was wrong, and I don't generate enough telemetry in my logs that is related to the timeout functionality. So I saw two problems about my current systems, which is the goal of chaos engineering. So validate or disprove my assumption. So the next thing that you will do then is the takeaways. So this was the demo. The takeaways that I want you to get out of this session are the following. So first of all, you may want to design, and let me put it a bit bigger. You may want to design your system for high availability by using serverless technologies and decoupling the long-running transaction with event-driven architectures. Implement retry strategies with exponential backoff and jitter. Implement logging metrics and tracing to understand what kind of information you still have or you need to add in top of your backend system, and validate the resilience of your workloads using chaos engineering. You can try this by yourself. So the demo that I showed, there is a workshop around the media content application. You can see the source code and deploy it on your application by yourself if you want. You can run the workshop as well, and you can also deploy a small serverless demo application. And you can learn more about the reliability best practices as told by AWS here. You also can inspect the Lambda Power Tools docs if you want, and you can also verify the resilience of your workload using chaos engineering blog post. Check the blog post in this link. And most important thing, I would like to have some feedback about the session because I want to know if you find it useful or not. And yeah, feedback is a gift, so thank you so much.